This is the German University in Cairo team, GUC team, Egypt, Cairo. Today we are presenting our project for the Reconfigurable antenna for the Antenna Propagation Society Symposium 2013 Student Design Challenge. The objective of our system is to demonstrate and to promote the idea of the reconfigurable antennas to students from the pre-college, college, and graduate students. Actually, I'll start with our transmitter. As we can see here, our transmitter is composed of a printed Yagi antenna array. The array is composed of 4 elements, 1, 2, 3, and 4. This array is able to produce up to 7 different patterns, starting from radiating from every simple element and going through radiating through 2 consecutive elements. Actually, we can acquire this through our feeding network. Our feeding network here is composed of 3 different switchable couplers. Our couplers is composed of RF switches. These switches are used to direct the power in different direction. Actually, we are using it to feed the network 2 terminals at the same time, or direct all the power to only 1 terminal. All the switches are operated, and all the schematic for the different configuration of our switches is controlled via our PIC microcontroller. This microcontroller is controlled through our computer here, and the system is operated through a ZigBee chip, which is acquiring 2.4 gigahertz of power. This system is able to be switched on and operating on a simple USB, or we having our separate power supply. Right now we are going to move to our transmitter part, receiver part. Our receiver part is composed of 4 different aperture patch coupled array. This array is acquiring it resembles the 4 arrays for the transmitter. As we can see here, we are promoting the different polarization, diversity, and angle diversity, because this array is able to produce different polarization, as we can see later, and different angles. If we move to the back of our arrays, this array is composed of 2 different feeding lines. The feeding lines can produce a polarization direction of X, or a polarization direction of Y, or a left-hand circular polarization. The same coupler that we're using here, we're using the same couplers, the RF switched couplers. Those couplers are fed through the PIC. All the software is reconfigured and programmed through our microcontroller, so we can have every different polarization and different combination of our system. This system can move in X direction with the different angles, and Y direction and CP. This direction is produced through our phase shifters. We have 2 different types of phase shifters that are using the idea of reversed coupled phase shifters. Actually, they are operated with the same RF switches that we have mentioned earlier. This switch's schematics also, as we can see here, is connected to our microcontroller. Here we can see the ZigBee chip, the one as the one we're using there, acquiring the same power, and also this is fed through a USB or an output, a different external power source. Right now we are going to demonstrate having a demo of our system running. So, as we can see here, we have developed a GUI that we can control the different array. As we can see, that we have a figure that shows which one or which arrays or which combination that we're using, and we have provided with the simulated array that we have simulated earlier with our simulators. Right now, my friend is going to operate one of the combination. She is going to switch on the ZigBee chip. And if we go to the other side, where we are operating on the simple ZigBee chip terminal, we can see that our receiver is receiving different powers. Actually, these powers is encoded in the ZigBee code, so we cannot read it right now. Actually, we're going to wait until we acquire all the combination that we have talked about earlier and then we're converting this code into a MATLAB code. So we can see all the powers distributed on all our polarizations that we had mentioned earlier. Our system is privileged because if we are thinking about switching output or switching between the receiver and transmitter, we can provide that. The main thing about our project, we can substitute one of the receiver or the transmitter with only one side. What I mean is, we can just use a receiver at the transmitter using the same design of the transmitter. We can replace this part with the same Yagi antenna configuration. All we have to do is do a little modification of the microcontroller so we'll be able to having the same results. The same applies for this part. We can replace the Yagi antenna with this aperture coupler and coupled line antennas. I think that we have finished all the combination. My friend here will show you that we are converting the results into a MATLAB code that we have developed earlier. Here we can see all the measured power results, starting from a simple linearly polarized with the phase of 45 degrees, ending up with circularly polarized with the phase 270. Actually, our system is a little bit basic because all we have to do to acquire the adaptivity of our system is to measure all the powers of all different combinations here. So what we are doing actually is going through every combination, just measuring the power. So we consider this as an advantage for we can use our system for research forwardly. So we can develop a better system that can acquire the best communication network through acquiring the best power. Our system can be fed differently. Our system is pretty flexible that we can feed every antenna with a simple Zigbee jack instead of having a Zigbee for the whole system, so we can acquire different power. Our system is flexible, as we mentioned earlier, so we can switch it between. The main thing that we acquire as a team, that we provide the educational value that was purposed by our team from the first place, that we can use this our simple design, so we can show for pre-college, for instance, the idea of different antennas, the printed antennas from the first place, and then for the college students, we can provide them with the idea of different polarizations, the idea of adaptivity of the system. For the postgraduate studies, we can tell you that we can modify the microcontroller so we can have a better system. We can optimize our system so we can reduce, for instance, the huge number of switches that we're using here. Actually, our system is, as we mentioned earlier, so we can sum it up, it's flexible, it's adaptable, it's a reconfigurable system that we can use for many purposes, educational purposes, and we can have, for instance, we can use it, we can change the polarization, we can change the orientation of the antennas here by moving it manually instead of using it electronically. Right now I'm going to introduce to you my team, starting from Mahmoud, going through Norhan already. Alright, as you can see here we have Karim, and as you can see here, we have our electronic genius. He's not part of our team, but he has helped us a lot with the electronics component and everything, Mr. Hassan. Thank you very much for listening and vote for us.